Hello everyone, my name is Zack Garrett and I'm going to give you a brief rundown of the history of logic since Aristotle. Now starting off with Aristotle himself, he was known as the philosopher by medieval philosophers. That just shows you how important he was in the history of philosophy. And in particular, he made a big impact on logic. Now, Aristotle systematized logic. He gave us rules for how categories interact. So you might think of categories like groups of objects. So you have categories like politicians or liars or illegal actions or cats, corgis. They're just groups of objects that have something in common. And Aristotle was the first one to systematize our rules for how sentences with these categories interact and the relationships between them. So we might look at a sentence like all politicians are liars, and we can then analyze what follows from that. Does it follow that some politicians are liars? Does it follow that it's false that no politicians are non-liars? And so Aristotle gave us a bunch of rules for manipulating sentences like these. Now, there are some limits to Aristotle's logic. In particular, it struggles with sentences, or many of the sentences in natural language, that talk about the relationships between sentences. So instead of talking about the relationships between categories, we might be talking about the relationships between sentences. So here's an example of something that Aristotle's logic might struggle with. The sentence there in orange, if A and B are both true, then so is C. Here we're not talking about the relationships between categories, but the relationships between sentences. George Boole was one of the first big revolutionaries in the history of logic. So Aristotle's logic stood for centuries, for millennia. It wasn't until the 19th century that we start to see some big changes, and one of the leaders of those changes was George Boole. So Boole noted that we could treat words like not and or and if as functions that map truth values to other truth values. So they map the values like true and false to other values. So here's an example of that in action. We might have the sentence Paris is in France. That's true. London is in Germany. Well, that's false. And then we have the combined sentence Paris is in France and London is in Germany. That's false. And it's because it's a function of those two other sentences. One of them is true, the other is false. When we combine them together, we end up with false, because that's the way the word and works. And you'll get different results if you swap in the word or if into that sentence in place of and. Now, all of this, the math behind this, is called Boolean algebra. So Boole was the winner in terms of getting one of the most important things in logic named after him. His contemporary was a guy named Augustus de Morgan. And de Morgan and Boole got along. They worked together a bit. It was De Morgan that made a bunch of discoveries alongside Boole, but unfortunately didn't get his name on the algebra. Now, De Morgan, despite not getting it called De Morgan's algebra, he did get a law of logic named after him. And you're going to study that more later on in this course. De Morgan's law is the connection you see there at the bottom. Neither A nor B is the same as not A and not B. So you can have neither chicken nor fish at the dinner. Therefore, you can't have chicken and you can't have fish. So those equivalences there, those connected sentences, are called De Morgan's law. The next big revolutionary coming at the end of the 19th century and into the 20th is Gottlob Frege. Frege took it even further in terms of turning logic into mathematics, although Frege thought math could be reduced to logic. And he noted that individual sentences could be treated like functions, not just ones that have the word and or if in them, but every sentence that makes a statement can be a function. So the sentence, Spot is a dog, we can think of is a dog as a function. Spot is the input, and then the output is the value true, because Spot is a dog. But if we put the Eiffel Tower in as the input, so is a dog, parentheses, Eiffel Tower, not going to be true anymore. Comes out false. And so this is a lot like the functions you may have learned in your math class in the past, like f of x equals x squared, where we can take an input and it'll give us an output. So it maps those inputs onto outputs. Sentences, according to Frege, do the same thing. They map inputs onto either true or false. Now, that may sound a lot like math, and logic, since Aristotle, has turned into a mathematical field, and a lot of the big innovations are coming from mathematics, but also from computing. So the Boolean algebra forms the central foundation of modern computing. The way that computers are built is by connecting together a bunch of logic gates, each of them representing logical operations like not, and or. And so Boole's innovations in the 1800s formed the groundwork for computer science in the 20th century. Now, since the mid-20th century, a lot of the big innovations in logic have come in the form of questioning this black and white view of the world that we get from classical logic. Because in classical logic, sentences can only be true or false, but some non-classical logics allow for shades of gray in the world. Graham Priest, who you see pictured here, for example, argues that sentences can be both true and false at the same time, a logic he calls the logic of paradox. Or some people argue that sentences can be true to a degree, rather than just wholly true or wholly false. Another big innovation recently in the history of logic, I say recently, but it was decades ago, is Saul Kripke's his discoveries when it comes to the logic of words like possible and necessary. So Kripke, as a 16-year-old working in a library in Omaha, came up with rules for understanding the meanings of the word possible and necessary, and a whole logic to go along with them that references other universes. So what is true in every universe, or true in some universes. So logic's come a long way in the last 200 years since the work of George Boole. But there was almost no innovation from the time of Aristotle all the way up to the 1800s. So because of this sort of haphazard bursts of innovation over the history of logic and the long period of stagnation, the conventions we use in logic, the symbols we use, the names we use for things are all mixed up. And that's going to cause some difficulty in learning logic, because when you look at one textbook, you're going to see different words and different definitions used from another textbook. Now that's fine, because they're all equivalent to each other. They're all saying the same thing, they're just using different words for them. So it's important here at the beginning of a class to learn those conventions. So like symbols, we use a bunch of different symbols for the word and. One of them looks like a little tent there, or a dot, or the ampersand you may be familiar with. Names for different kinds of arguments are all over the place, some of them even using the old Latin names from the medieval period, like modus ponens and modus tollens. So there's a lot of different names we use for things, different symbols we use for them, as a result of this sort of haphazard changes in the amount of like growth and revolution in the field of logic.